First, I'll discuss any doubts if you have in exercise 2. Mention the question in which you have doubt from separating mixture exercise 2. First, in MCQs, mention the question number. Anyone of you having a doubt in MCQs? Or structure questions? Page number 8. A fake banknote can be investigated by dissolving the ink of the paper. You are provided with 4 different inks from 4 different criminals. Describe an experiment to show which one of these inks is same as the ink from the banknote. You can use a label diagram to help your answer. So what we can do, so first we will extract the ink. How we can extract the ink from the banknote? So we can boil this banknote. They did not mention it is water soluble or insoluble, so you can mention any solvent. So we'll take water, a container which is filled with water. And we will add a banknote. We'll add a banknote and we supply heat energy. When we supply heat energy, so we extract the color. The color is removed from the banknote. Then we will filter and remove. Then use a chromatography. So using a chromatography, what we can do, we can place a sample, use a suitable solvent so that the ink will rise, and measure the RF value. And after measuring the RF value, we'll compare with different inks from different criminals. This is one way. Or the second way, another way, you can take a sample, means after extracting the ink, you can place the sample, the ink from the banknote. Example, this one is the ink from the banknote, and then this one is from criminal 1, criminal 2, criminal 3, and criminal 4. That means what happened? The one which rises to the same height, like example, criminal 1 ink was rising this height, criminal 2, 3 was there, and 4. So which one is present in a banknote? So you can identify if they rises to the same height, then the ink present in criminal 3 is same as in the banknote. But you don't have to mention which one matches, you just have to mention a procedure how you will carry out this. Then question number MCQs, question 6. A sample contains a mixture limestone, sugar and wax. Limestone, calcium carbonate, I told you most carbonates are insoluble except sodium, potassium and ammonium. So this will be insoluble, does not dissolve. Sugar will dissolve in water or soluble. And candle wax also, because wax is also insoluble or does not dissolve. So what is the correct way to obtain a pure sample of a sugar? If you want to obtain sugar, dissolve the mixture in dilute hydrochloric acid, filter and wash. Why this will not work? Because the acid is there, hydrochloric acid will react with sugar, so this will not be suitable. Dissolve the mixture in hexane. Hexane, it's organic compound. Organic compounds can dissolve organic substances. Wax is an organic substance. So what will happen if you mix in wax? If you mix the mixture or add a mixture to hexane, the wax will dissolve and calcium carbonate and sugar will not dissolve, so it will not be accurate. Dissolve the mixture in water, filter and evaporate, because what happened when you add water, so both limestone and wax are insoluble, so when you filter off, they are removed, so you are left with sugar solution. And how you obtain crystals or sugar from the water or from such solution? You can simply carry out evaporation. So that's why option C is the right answer. Solid X is purified in 5 steps. First 4 steps of purification are shown in the diagram. So in step 5, how is a pure sample of solid X obtained from a mixture Y? So first what happened, like these are the first 4 steps. First we stir, then we filter, then we transfer into evaporate, and then we evaporate. In step 5, how is the pure sample of solid X? So when you will do crystallization, you remove some of the water and the solid will appear. How I can remove this solid from the solution? So we can use filtration. Is it clear? Page 11, what's the question number on page 11? Look, you have in question 6, you have 3 substances. You have calcium carbonate, you have sugar, and you have wax. So both calcium carbonate and sugar and wax are insoluble in water, does not dissolve in water. So calcium carbonate is insoluble, sugar is soluble in water, and wax is insoluble. So if I add water to this mixture, what will happen? Calcium carbonate and wax will not dissolve, and when I filter, so they will left on the filter paper. So this will be a residue which is left on the filter paper. This will be residue as well, and this will be filtrate. So when you pass through a filter paper, both wax and calcium carbonate will left on the filter paper, and the sugar will pass through, that will be filtrate. And you can do evaporation to extract this or remove the sugar. Page 10, question number 2. Leaves from the tree contain a color pigment, so they contain a color which is not soluble in water. It does not dissolve in water. A student was given these two instructions to investigate the pigment which is there in the crushed leaf. Crush some leaves to extract the color pigment. Use the liquid extract to find the number of colored pigment in the leaf. Means how many colors are there in the leaf. Describe an experiment to carry out instruction 2. A space has been left if you want to draw. It will help to help your answer. You can draw. So basically what we can do, first thing we have to crush the leaves. So how we can crush the leaves? So we can use mortar and pestle. So whenever you want to crush like any substance, so you use mortar and pestle. So using mortar and pestle, you will crush the leaves first. And then how you will extract the color? So these crushed leaves, because they are not water soluble, so you cannot use water. So if it's not water soluble, you will use alcohol. So you will take alcohol and add these crushed leaves. And heat it. So when you will heat, the color is removed from these leaves and it will dissolve in alcohol. And when this color is removed from the leaf, what we call this solution is called an extract. Extract from the leaf. And this extract you will place on the chromatogram. You will use a solvent such as alcohol only can be used, and then measure the RF value. So first thing, use a liquid extract to find number of color pigments in the leaf. So how you can find number of color pigments? The number of the spots will give you number of the color pigments. If only one spot is there, it means that it has only one color. If more than one spot, it means it has more than one colors. And how you can identify the color? You can measure the RF value to identify which color is there. Is it clear? Question 2. E110 is a sunset yellow. Outline a method you would show that the presence of E110 in a food coloring means a food color contain E110. A space has been left if you want to draw. So what you can do? So you can take a sample, the food colors, and place it on the chromatogram. Then draw the origin with pencil. Place the food color. And then use a suitable solvent, as they did not mention that it is water soluble or no, so you can use water or alcohol, any one of them. So when you dip this chromatogram, it will rise. So how you can identify E110? So you will measure the RF value. How to measure RF value? Distance moved by spot divided by distance moved by solvent. So after measuring the RF value for E110, you will compare, after measuring the RF value of the sample, you will compare with the standard RF value of E110. If both RF values are same, it means that this contain the sample or the food color contain E110. Or there's also another way. What you can do, you can place a sample food color and you will have a pure E110. So you will have a sample and you will have a food color exact E110. So what happened? Maybe sample may have different color, but E100, one of the point matches with the sample. What it shows? It shows that it also contains E110. Is it clear? Question number 4 in page 8. A fake banknote can be investigated by dissolving ink. So what you can do, the same method, same technique, you will have a container which is filled with a solvent. They did not mention it is water soluble or no, so you can use any solvent. And you place a banknote. Supply the heat energy. So when you will heat this banknote, what will happen? The color will is extracted from the banknote. Then you want to identify, like you have 4 different inks from 4 sample of inks from 4 different criminals, and you want to find which one is having a ink that belongs to this fake banknote. So what you can do, you can use a chromatography. The chromatogram, you will place the sample, the extract. So one point you will place an extract, and then different inks from 4 different criminals, C1, C2, C3 and C4 are inks from 4 different criminals. So how you can identify like which criminal this ink belongs to? So you can measure the RF value, or you can identify which position the spots rises for different sample of inks. So the one which matches, you can see here, the sample matches with C3, so means this belongs to criminal 3. Or you can measure the RF value from the sample, and after measuring the RF value, compare with the RF values of 4 different inks from different criminals, and the one which matches, the one which has the same RF value, are same type of inks. Is it clear? Anyone else having a doubt in this?